Evaluate the definite integral from -1 to 1 of 2x over x plus 2 dx. We don't see any expression that is being raised to a power, and we don't see the exponent. And so we will let u be the denominator and see what happens. Let u be x plus 2, then du is the root of x is 1, the root of 2 is 0, so 1 dx. Dx is therefore du. Also, when x equals -1, u is -1 plus 2 because x is now -1, which is 1. When x equals 1, u is now 1 plus 2 or 3. And so the lower limit of integration in terms of u is now 1 and the upper limit of integration will be 3. Next, we perform the substitution, the definite integral. In terms of u, again, the lower limit of integration is now 1. And in terms of u, the upper limit of integration is now 3, corresponding 1 and 3. 2x over x plus 2 is now substituted with u, and we replace dx with du. There is still a factor of x in the integrand, which means we cannot integrate it yet. Because of du, the variable of integration is u, so every expression inside the integrand has to be in terms of u. We need to find a way to replace x in terms of u. There's no cancellation here. But observe that if u is x plus 2 and we want to have a substitution for x, then we simply isolate x and get u minus 2. X equals u minus 2. This integral is now the definite integral from 1 to 3, 2, but x is now u minus 2 over u du. 2 is a constant multiple, so we write it in the front of the integral. The integral from 1 to 3. The integrand is now u minus 2 over u, and then du. This is 2, the integral from 1 to 2. We separate this fraction, u over u minus 2 over u du. This is 2, the integral from 1 to 2. U over u is 1 minus 2 over u du. With respect to u, the antiderivative of 1 is u. Minus 2 is a constant multiple. The antiderivative of 1 over u is ln of u. And then we evaluate this from u equals 1 to u equals 3. Plugged in 3, we have 2 times 3 minus 2 ln of 3 minus, plugged in 1, we have 2 times 1 minus 2 ln of 1. Remember the ln of 1 is 0, so 0 times -2 is 0. Simplifying this, we have 6 minus 4 ln of 3 minus 2. So the answer is 4 minus 4 ln of 3. This is the exact answer. This is approximately -0.3944, rounded to 4 decimal places. For the second integral, since x plus 1 is inside the radical, we let u be x plus 1. Then du is 1 plus 0, which is 1, dx. So dx is du. If x is -1, then u is -1 plus 1, which is 0. When x equals 0, u is 0 plus 1, which is 1. So these will be the upper and lower limit of integration for the new integral. Rewrite this definite integral. We have the definite integral from, instead of -1 equals x, we have u equals 0. Instead of x equals 0, we have u equals 1. 2x, the square root of x plus 1 is now u, and we replace dx with du. There is still a factor of x in this definite integrals in terms of u. But observe that if u equals x plus 1, then x by itself is u minus 1. So we can rewrite this integral as 2 times the definite integral from 0 to 1, where x is now u minus 1, square root of u du. The square root of u is u to the 1/2, so this is 2, the definite integral from 0 to 1, u minus 1 times u to the 1/2 du. We then distribute u to the 1/2 to the expression u minus 1 to get 2 times the definite integral from 0 to 1, u times u to the 1/2 is u to the 3/2, minus 1 times u to the 1/2 is u to the 1/2. Then we find the antiderivative of each of the terms individually. The antiderivative of u to the 1/2 is u to the 5/2, 3/2 plus 1 is 5/2 over 5 over 2. The antiderivative of u to the 1/2 is u to the 3/2 over 3 over 2. There's no need to do a plus c here because this is the definite integral, but we evaluate from 0 to 1. Simplifying this, we have 2 times 2 over 5. Because divided by 5 over 2 is the same thing as multiply 2 over 5. U to the 5/2 minus 2 times 2 over 3 u to the 3/2. And then we plugged in 0 and 1. This is 4 over 5. Plugged in 1 to u, we have 1 to the 5/2 minus 4 over 3. Plugged in 1, 1 to the 3/2 minus, and then now we plugged in 0. 4 over 5 times 0 to the 5/2 minus 4 over 3 times 0 to the 3/2. But 0 raised to the 5/2 power is 0. 0 times 4 over 5 is 0. This is 0. So the answer will be 4 over 5 minus 4 over 3. The common denominator is 15. So we have 12 minus 20, which is negative 8. Negative 8 over 15 is the exact answer, and it is approximately negative 0.5333, rounded to 4 decimal places.